Good day. Today we're going to be looking at the complex numbers. Real quick, this is a Euler diagram of the real number system. This includes irrational numbers and everything from negative to positive infinity. However, this is only half of the numbers that we have access to. Sometimes we're going to encounter an imaginary number. We're denoting that with the letter I. If you take the square root of something like 9, it equals 3 because 3 squared is equal to 9. Now, technically, if you're solving an equation such as x squared equals 9, you get plus and minus 3. Again, that's just when solving an equation because negative 3 squared is also 9. However, when we take the square root of a negative number, such as the square root of negative 9, there is nothing in our real number system that we can multiply together to get negative 9 by itself. The reason for that is, if you multiply two positive numbers, it is positive, and if you multiply two negative numbers, it is also positive. This is where the imaginary unit I is introduced. It is the value of the square root of negative 1. If you have I squared, it gives you negative 1. So if you have something like the square root of negative 9, we know the square root of 9 is 3. And the negative part, we're going to bring out as an I. You should have seen this before. Now let's talk about it in depth in Math 4. All right, let's do some practice examples. A says square root of negative 64. I'm going to break this apart like I'm going to simplify the radical into square root of negative 1 times the square root of 64. Well, the square root of negative 1 is I by definition. The square root of 64 is 8, so I have I times 8, which is 8I. All right, for B, I'm going to do negative times the square root of negative 1 times the square root of 9 times 3. I have the square root of 9 times the square root of 3 to simplify the square root of 27. This gives me negative I times 3 times square root of 3. So my final answer is negative 3I square root 3. Try number C, letter C, whatever. Here in a second, at the end of the video, I'll show you the answer key. All right, solve each equation. I'm going to do A and B, and I'm going to let you try C, and I'll, again, show you the answer for everything that I did not cover at the very end of this lesson. All right. Subtract 9 from both sides. Take the square root from both sides. So when I take the square root, I'm solving, so I need plus or minus the square root of negative 9. So I get x is equal to plus or minus 3I. All right, part B. You cannot factor this, so we're going to use the quadratic formula. If you do not remember this, here's the tune you need to remember. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. A is your leading coefficient in front of x squared, b is the coefficient in front of x, and c is your constant. If I plug these in, x is equal to negative 4 plus minus square root of 4 squared minus 4 times 1 times 5 divided by 2 times 1. This is going to give me negative 4 plus minus square root of 16 minus 20 over 2. This is going to be negative 4 plus minus square root of negative 4 over 2. negative 4 plus minus 2I over 2. You can simplify this by pulling out the GCF on the numerator of 2 and then dividing, and it's going to give me a final answer of negative 2 plus minus I. B is finished. Moving on. To graph a complex number. A complex number is where we have one part of it as real and another part as imaginary. You graph the real numbers on what is normally the x-axis and the imaginary part on what is normally the y-axis. So if I was asked to plot these points, 2 plus 3i, I'd go to 2 on my x, go up to 3 on my y. There's my coordinate, negative 6 plus 5i, negative 6 up to 5. Okay, do the last two. For a Euler diagram with including complex numbers, it's the same thing as before for we did it for the rational part, or for the real numbers. The complex numbers is anything plus an imaginary number, and your imaginary numbers are such as negative 2i, well, anything of I, pi I, whatever you want to put. All right, let's do some math. Operations involving complex numbers. To solve this, first thing I want to do, and this gives you the solution already, that's all right. I'm going to show you how to get to the solution. The first thing I'm going to do is I'm going to take the I out of anything with a negative. So I have I square root 21 times I square root 21. This is I squared times the square root of 21 squared, because it's 21 times 21. This is negative 1 times 21, which is negative 21 as your final answer. Try B, and I'm going to do C. All right, I have I times the square root of 42 divided by I times the square root of 3. This is going to give me the square root of 42 over 3, which is 14. Your eyes cancel. 14. And my solution is the square root of 14. Try D. Addition and subtraction for these, you're just going to be combining like terms. So for A, I'm going to add 4 negative 5 to get negative 1. I'm going to add negative 5i and 8i to get positive 3i. I will let you try B. Don't forget with a negative to distribute. Well, let's just do it. I can take another 30 seconds to solve this real quick. Minus 5 plus 3i. This is negative 15 plus 10i. Finished. All right. Foiling these problems. First times first, first times second, second times first, second times second. That's how you FOIL. So 5 times 2, 10. 5 times negative 7, negative 35i. 3 times 2, 6i. 3 times negative 7 is negative 21i squared. Okay, so this is 10 minus 29i plus 21, because it's negative 21 times negative 1, positive 21. That's 31 minus 29i. Finished? I'm going to do B and let you do C. For B, this is a perfect square, so it's first times first, 16. First times second times 2, so 4 times negative 5 is negative 20, times 2, negative 40, I. And then second times second, plus 25, I squared. I am going to let you solve B from there. Division of complex numbers, and we're on our last page of this unit. I'm going to be very honest with you. You're not going to see this very often. If I am just going to grade something quickly, I would be okay with that, even though technically it's not in the simplest form. To make this in simplest form, you're going to multiply by the conjugate of the denominator. Now what that means is, for number A, letter A, I'm going to multiply by 3 minus I. Why minus? Because this one was plus. My numerator is the same. I'm multiplying with the same on top and bottom because essentially I am just multiplying by 1. Now when I do this, I'm going to get 15 minus 5I minus 15I plus 5I squared divided by, and the bottom is a difference of perfect squares, so 3 times 3 is 9, okay, it's just 3 squared, minus I squared. This is 15 minus 20, I minus 5 over, I realize that looks like the division symbol, minus 5 over 9 minus 1, minus negative 1, so plus 1. This is 10 minus 20i over 10. Therefore, my answer is 1 minus 2i. Finished. Try B. Now let's talk about the powers of I. In my opinion, once you see this pattern, it is really easy to do these. First off, by definition, I squared is negative 1. How about I cubed? Well, I cubed is I squared times I. This is negative 1 times I. This is simply negative I. I to the fourth, I squared, squared. This is negative 1 squared, which is positive 1. I to the fifth, I squared, squared times I. This is 1 times I, or just I. I to the sixth is I squared to the third. This is going to give me negative 1 to the third, which is negative 1. I squared to the third times I is equal to negative I. I squared to the fourth, that's negative 1 to the fourth, or positive 1. All right, look at the pattern. It's starting at I, negative 1, negative I, positive 1. Now go to the right side, I, negative 1, negative I, positive 1. There is a pattern here. To solve this pattern, you can do at least 2 ways. It gives you an example of how to solve it by dividing by 4 because of the 4 different parts of the pattern. personally, I do not like that method. And I've worked out my method on the right-hand side. My method is to do this. And you can see it on the right, you can pause it and write down, of course, but I'm going to talk you through it over on this side. Whenever I'm trying to simplify I to any exponent, the first thing I do is make that exponent an even number by subtracting 1 from it if it's not already even. So, I have I to the 24th, and what I have done is just pulled out one of my times i's. Okay? The reason I like even exponents, I can make I squared as a base. So this is going to become I squared, which of course is just -1, to the 12th power. Here's the reason why I like this. If your exponent here is even, that means I squared, -1, is going to come out as +1. If it is odd, then it'll be -1. So, this one is going to be +1 times I. And I am finished. I just have I, and if you check their method, they just have I. All right. Try this one, and then I'm going to work it. All right. I to the 58th times I. This is I squared to the 29th times I. This is -1 times I, or -I. And we are finished. All right, at this point, I want you to look at the answer key, write down the answers, and we will be done for the day. Have a great rest of your day.